All right, so let's start the class. Coordinate geometry is today's topic. Okay, we are going to actually focus on two-dimensional coordinate geometry. Coordinate geometry. Okay, coordinate geometry could be three-dimensional, one-dimensional. One-dimensional is just the coordinate line, and a couple formulas we need to know. Then I quickly move to the two-dimensional coordinate geometry. Okay, so remember this is a one-dimensional, right? Coordinate line, and every point, okay, every point there's one number corresponding to that. That's a point P. If that number is called A, okay, then we say A is a coordinate of the point P. Okay. Now, if we have another point Q and with coordinate B, then how do you measure the distance between P and the distance, usually called D, okay, P and the Q. And then you just take the difference of those two coordinates and take a absolute value because you don't know which one is large, okay? In this case, A is larger than B, then the A minus B is positive. Sometimes it's negative. So we don't care which one is first, okay? On the left, which one is on the right. So that is a distance formula. So one dimension is simple, okay? This is the only one we need to know, the distance formula. Of course, there was another formula called the midpoint formula. Midpoint, okay? So let M be the midpoint between P and Q, okay? So the coordinate of the midpoint, let's call the M, okay? M, okay. Then, whoa, this is funny. Okay, this P is moving to the side. All right. Then M is going to be the average value of A plus B. Okay, A, B could be negative. That is a formula. Okay, and it's easy to understand. So that's all we need to know. Nothing else. Okay, in the one dimension, yeah, coordinate geometry. Now, a typical example is that if you have 2 points, okay, and this is going to be 3/5, another point P, another point, and that is going to be Q, and that will be 11/3. Okay, so those are two exchange points. Okay, so we have to find the coordinate of the point R such that the distance between P and R is only equal to 1/3 of the distance between R and Q. Okay, so this is this is a good question. So distance between P and R is going to be the distance 1/3 of the distance between R and Q. Okay, so maybe we have one solution, maybe we have two solutions. Okay, so let's see. How do you solve this problem? Well, the coordinate of R is going to be denoted by X. Okay, so let X denote the coordinate of distance, and that is between P and R is going to be P is 3/5, right? Minus R, X, that should be 1/3, and R is X minus 11/3. All right, so question is how do you solve this type of equations? Right? Yeah, there is absolute value here. You have to remove it. Okay. That requires algebra. Now what we're doing is so-called coordinate geometry is just applying algebra to geometry problems using numbers, variables to solve the geometry problem. Okay, so if you have a, recall that if absolute A equals B, how do you remove the AB, the absolute value? It's equivalent to saying that A is going to be plus minus B. Okay, so AB could be negative sign, but the relationship is not necessarily A equals B. A could be negative B. So you have a two possibility. One is 3 over 5 minus x is going to be 1/3 x minus 11 over 3. Okay, so let's try to solve this equation and multiply both sides by 3, 9 over 5 minus. Okay, and then I'm going to move 3x to the right. Then I get 4x, right? So let's combine those two numbers. 15 and plus 55 here, right? So my answer is x is going to be 15 times 4. The top, that's going to be 82. Okay, 5 plus 7, right? 12. And then 82. 82 is going to be even number, right? So you can simplify a little bit. It's going to be 41, and then have a 2 here, 30. Okay, so 41 over 30 is a number. Where it is, it's slightly larger than 1. Slightly larger than 1, but less than 2. So somewhere here, okay? Somewhere here, this is a number. Okay, that's correct. But that's probably the only one solution. Okay, so distance between P and R is going to be 1/3 of the distance between R and P. So you assume that R is between P and Q, but R is not necessarily between P and Q. The second example, second case shows that. Okay, so it's minus 1/3 of x minus 11 over 3. Let's see what we can get. Similarly, you can multiply both sides by 3, then have a negative x plus 11 over 3. So I move 3x to the right, and here 9 over 5, it's minus 11 over 3. It's going to be 3x. Yeah, it's going to be 3x minus x, 2x. All right, let's combine these two numbers in fraction. 15. And, okay, so x is going to be a negative number. Okay, and that is going to be, let's try. Okay, so 55 minus 27 will be 28. Right? 28 divided by 2 is 14 or 15. So this number is negative, and somewhere here, let me draw the picture why that happens. So this is a 3 over 5, 11 over 3. It's a P and the Q. So there is a number here, R, P, and the Q. So this R, okay, also satisfies the condition because the distance between P and R is this, and distance between Q and I is this. So it could be still 1/3 of this. See, so there'll be two solutions. Now, it's easy to make mistakes to this type of problem. You assume that I is between P and Q. Then you have one solution. Okay, but using algebra, you can you will not miss another solution. Okay, so you will find the two solutions. All right, so that is first part of the coordinate geometry, one-dimensional, and we're not going to talk about three-dimensional. Okay, it's too complicated. So two-dimensional. Well, you have a so-called coordinate system. So this is called x-axis, this is called y-axis, okay? And every point in the plane corresponds to two numbers. Okay, one is you draw the line here, you get A, and draw a horizontal line, you get point B on the y-axis. So now you didn't use those two numbers to tell the location of that point. So A and B are called coordinates of the point P. okay? Coordinates of the point P. Okay, there are a couple of formulas we needed to know, okay? One is the distance. How do we use algebra to find the distance between 2 points? So you only needed to know the exact coordinates, right? P1, x1, y1, and here P2, x2, y2. And how can I measure the distance in the plane? The distance between P1, P2, or the middle point. We also want to find out the middle point. So there are a couple formulas we need to know, right? Distance formula. Okay. How can we find the distance? Well, you have to express the distance between P and P1 and P2 in terms of the coordinates. Okay, in terms of the coordinates. So the idea is very simple. Apply the Pythagorean theory. You draw the horizontal line, draw a vertical line, you get the right triangle. And then the distance between P1 and P2 is going to be the length of this triangle, this hypotenuse. Okay, so you have to do, so this is the x1, that's x2. This is a y1, that's y2. So this side, the distance is going to be y2 minus y1. And this side is x2 minus x1. So the distance between P1 and P2 by the Pythagorean theory. Now we're going to spend more time talking about Pythagorean theory. But at least this is just direct application. Okay, so it involves radicals right now. So that is the distance. Okay, and the middle point, let's call it x bar, y bar. How do you find the coordinates x bar, y bar? Well, you draw this line, this line, and those should be the middle points on each side. Okay, so that means x bar, the middle point, x bar, y bar, x bar should be the average value of x1 plus x2. That's in the middle. Y bar is going to be the average value. Okay, because that should be the middle point on the vertical line. Another one should be the middle point on the horizontal line segment. So those are the formulas. Okay. All right. So now we're going to solve some problems using this. Okay. Okay. Here's a question. Okay, I have a triangle. Okay, this will be 3 and 2, and here's going to be -1 and 3. How about that? Here's 0 and 0. Okay, so this is A, B, and C. We want to know what is area. Okay. Okay, how do you find the area? Well, I can find the distance, right? Yeah, the distance between A and B, the distance between B and C, the distance between C and A. Okay, we will have to do. Now, if you find all the side lengths, you can determine the area of the triangle. Okay. But the far side length is it will be probably not a good number. Let's look at the A and B. A and B is the difference of the x coordinates, which is 3 minus -1, right? Okay, and the difference of the y coordinates 2 minus 3. So what I got is a 4 square plus 1 square, 17. It's a very better number. It's very good, right? And the distance between B and C. That will be 3 minus 0 square, 2 minus 0 square, because, this is the difference of the corresponding coordinates, right? So it's going to be 9 plus 4, still a better number. Okay, it's a rational number. And then you look at A and C. So the difference of that coordinate, right? -1 minus 0 plus 3 minus 0 squared. So it's going to be 1 plus 9 square 10. So all those three sides are pretty bad, right? They are not integer lengths. They do not have integer lengths, okay? But we know that if you know three sides of a triangle, you can uniquely determine the area of triangle. But if you do this way, it's very complicated. Okay? If you do this way, it's very complicated. So the question is, how do you find the area? Okay, how do we find the area? Let's do this. Okay, -1 and 3, and 2, 3 and 2. Okay, and A, B, C. Okay, what is the best way to solve this? If you just focus on this triangle, you're not able to. You're still able to find the area, but the expression is very complicated. It's difficult to simplify. Okay. Think about it. Give you half a minute. Some of you probably can figure it out. You know, remember the Huron's formula, right? Where you have to find the area if you know the three sides. But Huron's formula is not the best way to use. Best method. Okay. So Erica says it's a 6. Surely good. Now here's the point. If you just focus on the triangle, if you know the three sides, let's call it A, C, B, A. Now, right, if you know the three sides, here's the Huron's formula. But don't suggest you to use this formula. Huron's formula for the area says that area should be equal to S minus A, S minus B, S minus C, where S is half of the parameter. And then half of parameter, how to do that? It's a fractions plus fractions. No, radical plus radical. Right, it's very complicated. You can use that, but you get a very complicated expression. So idea is very simple. We don't focus on the triangle. We use a rectangle to cover it. Okay. Then we calculate the area of each triangle, right? Those are the right triangle. You know, for the area, right? We already know the area formula for the triangle, right? Then you solve the problem. Okay. From here to here, -1 to 3 is 4, right? And from here to here, it is going to be 3. So this is a rectangle. So the area is going to be 3 times 4, that's the area of the rectangle, minus the area of the three triangles. Okay. Right, minus the area of three triangles. The one on the left, okay, is the height is going to be 3, the base is 1, okay, right, 3 and 1. And the one on the lower bottom, the height is going to be 2. The base is going to be 3, right, 3 and 2, right? And there's the area, the triangle. I think the height is 4, the base is 1. Okay, here's a 4 and a 1. So simplify it. 12 minus 3 over 2 minus 3 minus 2. Okay. So yeah, it's 7 minus 3 over 2. And then it's going to be 14 minus 3 is 11 over 2. Yes. So now it's, yeah, this we use we don't focus on the triangle. Actually, we use a subtraction to find the area of the triangle. So for now you got the idea, right? I want you to try this. Okay. So you're given the triangle with the vertices of 3. Okay. A, B, C. A has coordinates -2 and 1. B has coordinates 1 and 3. C has coordinates 4 and -2. Find the area of the triangle ABC. Okay. Please do it. Yeah, if you get answer, let me know. Okay. So you first you have to draw the rectangle, cover the triangle. Then you get the area of the rectangle and subtract the area of the 3 right triangle. Anyone has quick answers? So you draw the picture first. You need to quickly draw the triangle. Okay, so it looks like that. Okay, so you got the -2 and the 1. Okay, and you get 1 and the 3, and you get 4 and -2. Okay. So we don't care whether this is passing through the origin or not. So the idea is to make a rectangle, right? So it's easy to find the edge length. So let's figure out each side, okay? So this one, let's coordinate on 4 vertices. Here's a coordinate to be -2. Yeah, this is -2, not -2 and the -2, okay? And that will be -2 and 3. And then here will be 4 and I think 3, okay? So you got all those coordinates. Then easy to figure out the length, okay? -2 to 3 is this 5. And from 1 to 4 here 3. And from -2 to 1 is also 3. And here from -2 to 4 is 6. And from 1 to 3 here is 2. And from -2 to 1 is 3. Okay, so it's 3 plus 5. 2 is 5. Right? So now you can quickly get an answer, right? So the area is going to be 6 times 5, the area of the rectangle, minus the area of the triangle lower left, right? And minus the area on the right. And that is going to be 3 times 5 minus the area on the up left corner. Okay. So you will get, okay, so it's 9. And this is 15 over 2. And that would be 3. Okay. So, yeah. Okay. So now you do the subtraction. Okay. So 30 minus 12, right? So it's 18. So 15 over 2, right? So then 18 times 2 minus 15 should be 21. So 21 over 3. When you get the answer, you can look at this answer and say, oh, it's reasonable. Then you take it. Right. So this is how do we find the area of the triangle. Okay. All right. So our next problem is we are given the information. Okay. So this is already, we are told that this is a square. Okay. The vertices of a square, unless I made mistakes. Okay. The vertices of square A, B, C, D have coordinate -4 and 2, 1 and 14, 13 and 9, and 8, -3. Okay. Find the area of the square. Okay. So you're giving information here, right? -4, 2, and so you don't need to verify it's a square. Okay. So you already told that it's a square. You already told that it's a square. Okay. So the question is, how do you find it? What is the best way to find it? Okay, you can sketch the graph. Yeah, you have to sketch the graph. So a bunch of points here. -4 and the 2 is here. 1 and the 14 is here. 13 and the 9 is here. And other number is 8 and the 3. So a pretty good idea, you know, how does the rectangle look like? Okay. Square. How does the square look like? So what is the best way to solve the problem? Okay. So you have an A, B, C, and a D. I think since you already know it's a square, so all you have to do is just find the distance and the B, okay? And this edge length. So you only need just 2 points. So A is going to be, you know, -4 and a 2, right? -4 and the 2. B is 1 and the 14. So the difference of the x coordinate square, and then here's a 2 minus 14. So you get 5 square plus 12 square, and that is going to be 13 square. Okay. So 136. So the area A is going to be this square. It's a 13 square. It's a 169. Okay, good job. So be confident, just me. Don't put a question mark there. Okay, answer is answer. Okay. All right. So that is this is how do we find the area. All right. Now our next important topic, okay, we're going to focus on relationship of lines and linear equations. Okay, so that's the relationship between. Well, what does it mean? A given line, okay, how can you describe it? Okay, given line, how do we describe it? Given line, okay? We find out if you take arbitrary 2 points, okay? And we find out if you draw this rectangle, doesn't matter where we pick the points. So this is delta y and delta x, the change, right? And I can draw another one. And this is 2 points. We know this is delta y prime, delta x prime. We find out those 2 triangles are similar. Actually, similarity is not discussed yet, but I just say that this ratio will be the same, okay? So those 2 triangles similar, so the ratio will be the same, delta y over there. So this, you can enlarge delta y, enlarge, change the location, this will be the constant. So this is a constant, and the remain, it's independent of the point choice, the choice of the 2 points, P and the Q. And this is called the slope, okay? So this is a constant that's denoted by M. So that's called the slope of the line. Okay, this is very important, okay? Now, how do you find the slope? Just use the 2 points on the line, you can find the slope. So let's take a look at this. So we have 3 and 3 and 4. We have here, and it's going to be 6, 6, okay? So these 2 points on the line and the slope. And you draw the triangle, right? The triangle, okay? So the difference between 3 and 6 is a delta x, that's delta y. Let's find out, right? Delta x from 3 to 6 is going to be 6 minus 3, it's going to be 3. Delta y is from 4 to 6 is going to be 6 minus 4, that's a 2. Okay? Okay. So therefore, the difference is going to be, right? So it's going to be delta y over delta x. So it's 2 over 3. So that's a slope. It doesn't matter where you choose 2 points. You have another point maybe, and you should get the same point. Then okay, just look at this example. And I have another point, arbitrary point. Let's call it P. And I'm going to call it coordinates x and y. If this is a point on this line, what you can tell? Yeah, you can use that point to denote, to calculate the slope, right? If you use this point to calculate the slope. And what is the difference between, right? So delta y is the difference of, delta y is going to be the difference of 4 minus y, right? Right, it's the difference of the y coordinates. Delta x is going to be 3 minus x. So the slope is 4 minus y, 3 minus x. Okay. But I know that the slope is a constant, it's independent of the number. So this should be equal to 2 over 3. Okay. I can also, of course, I can change it, like y minus 4, x minus 3, doesn't matter. So what I get is I multiply both sides by x minus 3. So I get a relationship between x and y if the point P is on the line. So this is in a relationship between x and y. If P and was coordinate x and y is on the line with slope of 2 over 3. okay? Right, so that is called a linear equation. It's a no x squared there. That's a linear equation. So a line gives you every line you can describe it using the equation. You want to use the algebra to describe the line, and this is a so-called equation, which is describes the relationship of the coordinates for an arbitrary point on the line. Okay. And from, you can rewrite this, y equals 2 over 3 times x minus, multiply this out, minus 2 plus 4, 2 over 3x plus 2. Okay, so that is going to be an equation. Okay, this another, so there have been many forms of the equations. Okay, and but what is unchanged is this number. So if you, this is always a, yeah. The above equation indicates the line passing through the point 3 and 4. Okay, and how about the second equation? What you can say from this equation? Because the point disappeared, but you still get the point. Okay, when x equals 0, the y value is 2. So this gives you the so-called y-intercept. Okay, why? Because when x equals 0, y is 2. So that means this is a 2. It looks like that. Okay, this is called the y-intercept. Okay, 2 is the y-intercept. You still, so the it gives you more information. Not only the line passing through the point was coordinate 0 and 2, that point is on the y-axis. Okay. So conversely, right? Conversely, given a linear equation, an arbitrary linear equation, like 2x minus y equals 5, right? Now what you can read from that? Okay, this tells you the relationship between the coordinates of the point on the line, because it's a linear equation. And I can put maybe minus 3 here, okay? So that's what they get, right? Now what you can get from this? Well, you can say 3y equals 2x minus 5. So y equals 2 over 3x minus 5 over 3. So you get this standard form. Okay, so you can get as a slope m equals 2 over 3. You can also get the y-intercept, okay, which is negative 5 over 3. So because when x equals 0, right, when x equals 0, the y value is going to be 5 over 3. So this is a point on the y-axis, and this is a point on the y-axis. It looks like that, okay? Negative 5 over 3. So the line passing through that point. Okay, so back forward, given line, and you can get the equation. A linear equation, conversely, you can get the line. Because if you know the point, if you know the slope, then you can uniquely determine the line, because the slope really tells you if this side is 2 and this side might be 3. Okay, so you can you get that point? Another point, because 2 points uniquely determine line. Well, you can do that, right? So this is a 0 and negative, yeah, 0, negative 5, right? Let's get another pair of another point on the line. So that means another point, you have to increase x by 3, increase the y value from negative 5 over 3 plus 2, okay? So this is a coordinate. This is the coordinates of another point. So that's the equation, linear equation and the line, okay? So let's take a look at the following problem. I want you to do that, okay? what is slope of the line? The line is given by 2x plus 4y equals -5. And find 2 points on the line. Okay, so equation is given. So please please work out this. So of course, the 2 points, different students give me different points. Okay, please work out this. Okay. So let's try it. First of all, you rewrite this equation, right? 4y equals -2x minus 5. So y is going to be 4 divided by 2 is 1/2, and 5 over 2, right? Over 4. Okay. So at least you get 1 point. So the slope m is going to be -1/2. Okay. The next one is 1 point. You know, x when x equals 0, and this is a number. Okay. Another one, we can choose anyone, okay? So you can let x to be 1. When if x is 1, let's calculate, right? X equals 1, y equals -1/2, minus 4 over 5. So I get -2 over 4. So it's -7 over 4, okay? So then -7 over 4 is another point, okay? That's it. So good job, Nina. All right, so let's do another problem. Find an equation in general, okay? Well, in general form for the line. Okay, so for the line, so here's a point. Parallel to the line, 2x plus 3y equals 1, and passing through a point. Passing through this point. Okay, what does that mean? First of all, let's say, here's the important fact. 2 lines are parallel if and only if they have the same slope. Okay. The reason is that if this is a line, right, in the space, and this another line parallel to that, so you can parallel translate, so you get same identical, right? So that's why they have the same slope. If they do not have the same slope, eventually these 2 lines intersect with each other. So this is easy to understand. Parallel lines have the same slope. Then the 2 lines have the same slope must be parallel. Okay. So now, so you can use a given line to find the slope. So 3y equals negative 2x plus 1, y equals negative 2 over 3 plus 1/3. Okay, so that is given. So this is slope. And our new line will be negative 2 over 3x, but what we don't know is the y-intercept, right? So we don't know is those two lines are parallel. It's guaranteed. Okay. All right, so what they have to do is find determine the variable b, the y-intercept. So when x is negative 3, y should be 1. So this is the equation. Okay, so you get that is going to cancel. It's 2 plus b. B is going to be negative 1. So finally, I got the equation y equals negative. Okay, it's minus 1. Yeah, good job, Nina. Okay. Now, then you will say, how about the perpendicular case? Before we do that, let's look at this problem. Okay. How do we figure out the two lines are perpendicular? What's the relationship between the coordinates? Okay. So this is a point. Okay. Okay. So it has coordinates. This is a line, right? So let's call the slope. This line L1, right? And another line should be perpendicular. Let's look at the special case. So L2. So that point moved to here. But does the coordinate change? I think the y coordinate becomes the x, the negative b. Okay, so that's the relation. You can figure out the coordinates. These two triangles similar, identical, conclude. Okay. So these two triangles, if you rotate it from 90 degrees, they should get the same. Okay. Okay. So the slope for this M2, okay, this should be A over negative B. Okay. The slope here, M1, is going to be B over A. Yeah, they're all passing through the origin, so the difference. And then what you see that M1 times M2 is going to be B over A times negative A over B, which is always equal to negative 1. Okay, so that's the relationship. So we came to the following conclusion. Okay, two lines are perpendicular to each other. Okay, if and only if, okay, M1 times M2 equals negative 1. Okay, that's slopes. Okay, so now you can do the following. Okay, if the line at negative x plus 5y equals negative 1 is perpendicular to the line 5x plus ky equals negative 2. What is k? Okay, so you can try to determine the variable k so that those two lines are perpendicular. But all you have to do is simplify the equation. Like 5y my negative x plus y equals negative 1. I can rewrite 5y equals x minus 1, y equals 1/5 minus this. Okay, the other side, ky 5x plus ky equals negative 2. So ky equals -5 minus 2, y equals -5, kx minus 2 over k. So you compare those two coordinates, okay? Compare those two coordinates. 1, 5 times -5 over k is going to be -1. And k equals 1. All right, k equals 1. All right. Yes. All right, so now we take a look at a different type of problems, not talking about equations, okay? So we have a 3 points. This is a mass const problem. 3 points has coordinates. Some are given, some are not given. P plus 1, here 3 are on the same line. Okay. So what is P? Another question is if Q1 is on this line, what is Q? Okay. So how do you solve this problem? So they are on the same line. So how do we don't know how to draw it? There should be the same line. 1, -4, P -1, and P plus 1 and 3. Okay. So that means I think we should find the slope first. But if you use this pair of points, you probably can determine the slope quickly. So the slope m is going to be the difference of the two y coordinates, right? It's going to be y1 or 3 minus -1, and the p plus 1 minus p, okay? So that's why I use this pair of points. So that is going to be 4 of 1, which is 4. The slope is 4, okay? Once you know the slope, you can use this pair of points to find the p. This should be also equal to -1 minus -4, p minus 1, right? So it's going to be p, okay, 3. Right, so now 3 over p minus 1 equals 4. So you get 3 over 4 equals p minus 1, p is 3 over 4 plus 1. I think it's going to be 7 over 4, not the 2. Okay, 7 over 4. Okay, and then you determine those 3 points already. Now, if the point Q1 is also somewhere, right? Q1 is on the same line, and just use the same slope, okay? This is also the slope should be equal to, right? The slope, what do we got? Slope 4. The slope is 4, but you can use these 2 points, right? So -4 minus 1, 1 minus Q. And you calculate this. So you get 1 minus Q equals -5 over 4. And then Q equals 1 plus 5 over 4, which is going to be 9 over 4. Okay, so that's it. Okay. Yeah. So let's understand the geometry of the slope. Okay, if you have a bunch of lines, right? That's a special case. So y equals kx. Y equals x is a line passing through the origin, and then the slope is k. So when k increases, and then this line goes to that direction, okay? So as k increases, so more vertical, okay? So the geometric meaning of the value of k is going to be, if this is delta x, this is delta y, k is going to be delta y over the x. Okay. So when you increase, keep the value, you see, keep the value delta x equal to 1, then when increase the value of delta y, then you make the line more vertical, and then yeah, right. So when delta x can be 1, right? If you set the delta x to be 1, then yeah, this is it's more vertical if k approaches infinity. Okay. So the line becomes more vertical, more and more vertical if k as k increases. Okay, as k increases from positive. Okay, so the y-axis, this is also strict line. You cannot talk about slope. If you have to talk about slope, it must be infinity. Okay, so my question is, what is a slope of a vertical line? Okay, no definition, because the slope of the vertical line, okay, that's a special case. And then if you have to talk about slope, it is infinity. Okay, negative infinity and then positive infinity, doesn't matter which one. Okay, the slope is infinity. Okay, you cannot define the slope as a finite number here. Okay, now when slope is very large, but it's not infinity, then the slope is almost vertical. But in this case, m is positive, almost the infinity, right? And this side, the slope is negative. It's almost negative infinity, okay? Almost. Well, this is my notation. So you can imagine horizontal line, the slope is 0. Okay, horizontal line, the slope is 0. Okay, so this is about the geometry meaning of the slope. Okay, and it's a ratio of the increase in the y coordinates over the ratio over the increase in the x coordinates. Okay, that's the geometry meaning. So that's all about the coordinate geometry. I don't have time to talk about the circles and how to do parabolas. Okay, so that will be on our the course. So this actually will be high school math. Okay, but we should know the lines. Okay, we should know the lines and the triangles in the plane. Okay. So this is the first part of geometry. Use the algebra to study geometry, and the next lesson will be on angles. We're going to talk about angles. Right? Then we're talking about areas, triangles, more general topic. Okay. Then followed by Pythagorean theory and applications.